Hey Cyborgs, we are on location underneath a 2005 Ford Ranger pickup truck examining the components of its power steering system. You might think that turning a car is actually pretty easy. Turn the wheel, you need some sort of mechanism to change motion like this on the steering wheel to side-by-side motion that actually changes the angle of the wheels. This would be the case if cars didn't weigh several thousand pounds. And so the steering system in a car actually involves a component, this metal component, that magnifies the power of the driver turning the steering wheel such that the actual wheels move with relatively little force needing to be exerted by the driver. And that means that the steering system has a number of components to make that force magnification process work. In fact, we have to pump hydraulic fluid into high pressures into this assembly, and that pumping occurs only when the engine is running. If we actually poked up inside the hood of the car, we could examine where the power steering pump is connected to a belt that's connected directly to the engine. And so we're seeing components come out. We can just call this our power steering assembly. The tie rods on either end emerge from the power steering assembly and connect up to the wheel assembly and the tie rod knuckles. And so what we're actually going to do is I'm going to start the car, and since you're underneath the car, you'll be able to see the power steering components work together to move the wheels from side to side. All right, give me a second. I'm going to start the car and enjoy watching the power steering system come to life. We're here in the cab of the 2005 Ford Ranger, and we're investigating the components that make the steering system of this vehicle function. The car is off, the engine is not turning. Therefore, the power steering assembly is not receiving pressurized hydraulic fluid. So I have the keys in the ignition, and I have the steering column lock off. So I am now attempting to turn the wheels without any mechanical assistance from the power steering system. And you can see that this is not something that I would want to be doing if I were traveling at a high speed. Now granted, these tires are on gravel, but you'll notice the difference. If I start this car up, I can feel the steering becoming easier because the system involves using mechanical advantage to magnify the force of my hands on the steering wheel to actually turn the wheels themselves. Let's go in and make a diagram of our system, and we can use that process to help us gain insight into how it is that computer systems work together to do some pretty clever things. Welcome back from our field trip to the Ford Ranger. We examined the steering system within that vehicle. Let's practice creating a system diagram of the steering system. Remember, you're choosing your own non-computer system to draw a diagram of. You'll take a picture or you'll upload that diagram somehow to a word processing document as laid out in the Work Products section of our weekly guide. For review, in the video, we found obvious components within the steering system. For example, the steering wheel. That's a little bit big. Steering wheel sits in the cab, so we could label the cab like this. Notice, steering wheels aren't flattened ovals. We are symbolically representing components of the system so that we can understand how they're related. The steering column extends from the wheel down to the power steering assembly that's underneath the car, which we saw. So I'm drawing the power steering assembly, and I can label that. In fact, we can use a different color for labeling. Let's use brown for labels. This is the power steering assembly. out of that power steering assembly comes the tie rods, which connect the power steering assembly to the actual wheels of the vehicle. Here's a wheel, here's a wheel, and we can label what these components' names are. Tie rod, steering column, our system diagram is missing an important element, which is, what do these lines mean? I have a power steering assembly, and then I have a line going to the wheel. So what is being transferred? What is moving between our power steering assembly and the wheel? In this case, we're going to pull in a little bit of physics. We would say torque is moving between our power steering assembly and the wheel, meaning that twisting force. It's not fuel, it's not electricity, it's not oil, it's actually mechanical force that is moving between the systems. This is very common in all sorts of mechanical mechanisms. Our steering wheel, the steering column, the tie rods, the power steering assembly, and the tie rods together make up our steering system. Now let's think about if we want to categorize what some of these components do. Many systems have a control component, meaning some way for the user of that system to impact or control how it functions or behaves. So we could go ahead and label the wheel as a control component. We could think about the wheels themselves as an output component. That's because we don't have any actual material flowing through this particular system, the output component is more of a theoretical idea. Now, as with any system diagram, it's usually the case that that system isn't existing in isolation, meaning there are secondary systems that connect even into this steering system. For example, the power steering assembly actually has relationship to the hydraulic system in the car. And that involves yet another set of components and relationships. So we can say that there is a power steering pump which is connected to the power steering assembly with a to and from flow of hydraulic fluid into and out of the power steering assembly. You get the idea. So now we're going to transfer our knowledge over to computers and how they are functioning as a system. With this as a background, we should have an idea of where we're going with the computer system, whose components and their functions are probably slightly less familiar to you, hence you're taking CIT 100. So we're going to jump into the computer and look at how it's composed.